Hello again. This is a continuation of section 4 on exponential functions. So we're going to, again, be good note takers and label what we're doing. So this is exponential functions applications, because that's where I left off in the last video. And again, applications mean word problems, okay? Real life situations. So here's a scenario. The function P of t equals 300 times 1.025 to the t gives the population of a town, P, in thousands of people. Make sure you take notice of that because units are important. T years after 1980. Okay, and make sure you take notice of that as well, because that's going to affect your timeline and what numbers you're going to be using as inputs. So, as I've said in previous videos, the first thing that you should ask yourself is, what is my input? What is my output? Okay, everything should always have a base in input and output. So, even if the question's not asking me this, I'm going to do this, or you should do this, okay? In this situation, what is the input? What's being plugged into this situation, okay? Or in other words, what's going to happen independently? Well, time is going to go by independently, or just looking at the way the function is set up, t is what's inside the function. So the input here is t, and we're going to put the units on that as well. That's years since 1980. Okay? That means by default that the output is p, but again, that's what's alone over here. Okay? So the output is p, which is the population in thousands. So thousands of people. Okay, important to include the units on that. What's happening to the population? What do we know about this, looking at the function that they're giving to us? I can see this is exponential because it fits f of x equals ab to the x. Okay, I know they're not using x as input, but it's the same format. Okay, so this is an exponential. That means that I should be able to pick out that important information from the previous video. I know that my factor is 1.025. And I also can pick out that my y-intercept is 0,300. I should be able to pick that information out because, again, I'm just comparing this to f of x equals a b to the x, okay? And I know what a and b mean. So let's answer some questions based off of this knowledge. Is this town growing? Is the population growing, or is the population decaying? Well, the factor is going to tell us that. This factor is larger than 1, so this tells us that we have population growth because the factor is larger than 1. And now they're asking, by what rate is the population growing? By what rate is the population growing? Well, that has to do with our knowledge of the connection between factor and rate. The factor is 1.025. Remember, factor is how much you get to keep. So if I turn this into a percentage, I am keeping 102.5%. But I don't want to count the original 100. So I remove the original 100%, and I'm left with 2.5% growth. If you want to see the work for that, remember that rate is factor minus 1 times 100, or, again, this all depends on how you think about it, factor times 100, because you're turning it into a percentage, minus 100, all right? This all depends on how you want to think about that. But in other words, it's the 1.025, which as a percentage is 102.5. This is kept. This is how much we have every time. And that means that if I take 102.5 and take away 100%, 2.5% is just the gain. Okay, so it's a 2.5% gain or increase. So that tells me that the population is growing at a rate of 2.5%. And words answer words. You're going to hear me say that quite a few times every time we do word problems. You need to make sure you're answering in complete sentences, or at the very least with units, so that you know what question you're answering. So the population is growing at a rate of 2.5%. What does the y-intercept mean? So we've already picked out the y-intercept. So now we're being asked to interpret the y-intercept in context. And you're going to see this and hear this phrase a lot, okay? In context. In context means in the situation of the problem. It doesn't mean that you're going to explain to me what a y-intercept is, okay? We're going to assume that you know that. In context means in this situation, in this real life scenario, what is that ordered pair representing? So we know what the ordered pair is. We had that stated before. It's 0, 300. Basically, I'm asking 0 what? 300 what? What is the practical meaning of this ordered pair? This is why stating your input and output somewhere before you start will help you, because my input is years since 1980. So if I'm in year 0, that must mean I'm in 1980, because no years have gone by. And my output is population in thousands. So that must mean that the town has 300,000 people. And that answers my question right there. So I have half of it done already if I state the input and output. So that's what I'm going to write as my sentence. In 1980, because again, no years have gone by, the population was 300,000, remember the units on that, people. All right. Last question relating to this problem. Okay, and because I'm turning the page, I'm just going to rewrite the formula. So it was P of t equals 300 times 1.025 to the t. Okay, the last question is find the population in 2005. Well, first things first, I need to know what they're giving me here. They're giving me a year, so I know that that's input, but I need to figure out how many years after 1980 is this. So I have to know what 2005 minus 1980 is, because that's my starting year. So this is 25 years since 1980. Okay, that's what I need to know. So I'm really using a t value of 25 here, because that was what I was measuring, was years since 1980. What is this asking me to do? Now I know that t is 25, So I'm being asked to plug 25 in for t in the equation. So I want to know what p of 25 is. That's going to be 300 times 1.025 raised to the 25, okay? And remember, I always say plug in with parentheses, okay? If you put this in your calculator, it's going to give you a decimal, okay? It's going to be kind of long. We don't need to carry out all those digits. We're going to approximate, which is the squiggly equals here. And we're going to say that this is 556.183. Okay? This squiggly equals means approximately. And you're going to want to do that anytime you are chopping off decimal places, okay, and rounding appropriately. So remember your rounding rules. You look at the number immediately next to it, immediately to the right. If it's 5 or higher, you round up. And if it's below 5, you keep it the same, okay? So remember your normal rounding rules. The reason why I'm going out to 3 decimal places is because I know that my units on output were thousands of people. I know that thousands of people has 3 zeros. It's got 3 other decimal places. So I want to make sure that if I talk about this in thousands, that I have enough decimal places where I can read this as thousands. So now I can write all of this in a complete sentence. In 2005, the population was approximately 556,183 people. And I'm using the word approximately even in my written response, even in my sentence, because I still rounded that number. It's not exactly this number, okay, but we're rounding it to that number. Word problems are very involved, okay? So I'm trying to give you strategies that are going to help you decipher what each question is asking, okay? Vocabulary is very important, but stating the input and output will make your life easier. So I hope this video helps. If you have any questions, please let me know, and I'll see you in the next video.